beyond the differences between robots in terms of mechanisms. There are also differences in terms of purposes, that is to say in terms of reasons why they were built by their creators, why they were tested or spread. Several big families of use purposes can be distinguished. Concerning robots in our society, one first big use family is work and exploration. A second big family is assistance to people, helping humans in their daily tasks. A last big use family is using the robot as a thought tool to assist scientists to try to model and better understand some cognition, learning mechanisms with animals. First, let's talk about the working and exploring function. Among all the robots used in the world, most of them are used for tasks in manual factories. There are more than 9 million industrial robots in the world. There are many. At an early stage, companies got interested in these machines for several reasons. First of all, they can execute arduous and tiring tasks that are not motivating for humans. For example, when manipulating very heavy or dangerous parts in factories. Then, they got interested because these machines are able to execute a number of tasks. Not all tasks, but some very quickly, more efficiently than humans would. Sometimes, some companies are interested in the robotics field because collaboration between humans and machines produces better quality work, in every sense of the word. Better than if there were only humans or only robots. For example, in the industrial field, from a historical point of view, the first industrial robots appeared in the 60s. In particular in 1961, the Unimate robot was put to use in a General Motors factory. Since then, robots have been spread out in the automobile field, but not only there. In other fields too. For instance, in farming today, a lot of robots help picking fruits and trees, help filling bottles, help putting food in boxes, sorting them out and tidying. With robot types used to work and explore. Sometimes there's no other choice but to use robots, because they are sent to explore or work in places or environments that are too dangerous for humans, or places humans can't reach. An environment which is too dangerous for humans is nuclear plants where there is radioactivity that need maintenance. To prevent accidents, these places need maintenance. We must be able to go there. Remote-controlled robots are often used. Other contexts can be dangerous too, for example, when inspecting a boat's hull in the harbor or at sea to try to prevent accidents that could result in environmental disasters. Most of the time, it is not safe for humans, so robots are sent. At last, there's a very complicated place to go, which is space. Space is a field in which robots have contributed a lot to the world exploration. Thanks to humankind via robots. To begin, robots were sent on the moon in the 60s. The first robots arrived on the moon in 1966 with the Surveyor probe. Then, there were a lot of Russian robots like the Lunokhod and American robots like the Mariners. More recently, robots have been deployed on Mars, like Spirit and Opportunity. Thanks to these robots, traces of water have been detected, which gave way to great scientific leaps. Another family of purpose use of robots is people's assistants. In particular in today's society with physically or mentally disabled people. New robotics technologies have been developed to help them live more comfortably and more connected to their environment. For example, for physical disabilities, robots help to sit or stand. which allows a certain physical autonomy, for mental disabilities for example. For memory handicaps, robots can help stimulate and remind schedules. Remember, encourage contacts with the family or with medical environment. In this field, there are more and more robots in healthcare settings to assist surgeons. For example, there are some robotics, microscopic, endoscopic technologies that allow to explore inside the human body. Some robots are developed within the framework of prostheses. When a human has lost an arm or a leg, for example. Nowadays, there are robotics prostheses that try to physically replace these lost limbs and to control them in the most natural way. Another use family of robots that may not be obvious for everyone, but nevertheless is essential, is its use in science labs as tools to model and better understand life. In particular, learning and adaptation mechanisms. How do animals and humans in particular manage to acquire new know-hows? Manage to adapt to a changing environment? This is one of today's science's great mysteries that is difficult to penetrate because learning mechanisms imply interaction between several mechanisms on different levels of space and time, inside the body and the brain, and also of the brain with the body itself, and of the body with its environment. This interaction is even more complex, as each time body and brain interact with their environment, the brain changes and so do the interaction modes. Today, there aren't many tools to understand the complexity of these systems. In physical science, there is an old tradition that is to study complex systems, such as those at the root of the galaxy's creation, at the root of the creation of ice crystals, or to understand climate or weather evolution, for example. In physics, computers have been used to make models or simulations for a long time. In life and cognition sciences, robots have been used for decades. Like physicians use computers to understand climate and weather, robots are used to model some aspects of this complexity. Interactions between the brain, the body and the environment to help us better understand them. For example, they can be used to model some neuronal systems linked to the motor control. How children learn to move their hand in their visual field, thus to coordinate perception and action. The interesting thing is that as it is an artificial brain model, you can turn off as many times as you want some parts of the neuronal network and understand the impact it can have on behavior and learning. Experiments can be carried out to differentiate the brain and the body's contribution towards locomotion. Robots can be built with the same shape, the same geometry as a human body, and so even without a brain, when there's a good geometry, it can automatically generate steps that resemble humans. To make an experiment with animals where the nervous system would be separated from the body isn't possible to do for practical reasons, but most of all for ethical reasons. Robots allow a number of experiments that enable to bring our intuitions and scientific theories forward. Beyond motor control, there are currently several labs in the world that focus on language learning and on how an organism can acquire new language elements when interacting with social partners. Interdisciplinary collaborations are set between digital science and robotics, on the one hand, developmental psychology sciences and neuroscience, on the other hand.